So hi and hello. Welcome to our channel named Elvo Exploration. My name is Samir and today we will going to learn about insertion sort. When we have a small size data set or a running stream of data or a partially sorted data, at that time we generally apply insertion sort algorithm. So let me take a practical scenario that insertion sort works. Consider a people playing a cards. Now a person is having a number of cards on its left hand. Now he picks a card with his right hand and put that card in its correct position by comparing the cards that he has from right to left. In this way, insertion sort actually works. So here in that scenario, the number of cards are limited and it was a running stream of data, and actually it is a partially sorted data. So let me take an example and show you how actually it works. Now we have an array of 6 elements with element 25, 17 and so on. Now we put the first element 25, and since it is actually only one element, so it is actually in sorted order. So we will put here 25. Now we pick the second element, that is 70. Now we will compare with the elements which we have. Here we have only one element which is 25, so we will compare 25 with 17. And we know that 17 is actually smaller than 25. So what we will do, we will shift this 25 on right side and we will put 17 here. Now again we pick next element, that is 42. Now again we will compare 42 with 25. Now 42 is actually greater, so it should lie on the right side only. So 42 will come here only. Now again we will pick element 8. Now observe here, 8 is actually smaller than 42. So what we will do, we will shift 42 on its right side. Now again we will compare 8 with 25, in which 8 is actually smaller. So we will shift 25 on its right side. Now again we will compare 17 with 8, in which 17 is smaller. So we will shift 17 here. Now this space is vacant, so we will put 8 here, right? Now again we will pick element 93, in which we will compare with 42, and we know that 42 is actually smaller than 93, so 93 will come here. Now again we will pick the next element, that is 56, okay, and again we will compare with 93, in which 93 is actually greater. So what we will do, we will just shift 93 here and we will compare with 42, in which 42 is smaller, so 56 will come here. So we can see that now the array is actually sorted. So in this way the insertion sort works, in which we pick an element and we put that element in its correct position where the data is actually sorted. Let me take one more example and show you. Now here we have a second array in which we have 6 elements here also. So we will pick first element, that is 67, and since it is only one element, we will put here as it is. Now we will pick the second element, that is 12, and now we will compare with the elements that we have. We have only one element, that is 67, so 67 is being compared with 12 and 67 is greater, so we will shift on its right side. Now this place is vacant, so we will put 12 here, right? Now again we will pick the third element, that is 39, and we will compare with the elements that we have from right to left, in which 67 is greater. So what we will do, we will shift 67 here. Now this place is blank. Now again we will compare 39 with 12, right? And we know that 39 is greater, so we will write 39 here only. Now again we will pick the next element, that is 81, and we will compare with element 67, in which 81 is greater, so we will put 81 here only. Now again we will pick the next element, that is 21, and we will compare 21 with 81, in which 81 is greater, so shift 81 here. Now again what we will do, we will compare 21 with 67, in which 67 is greater, so shift 67 here. Now again we will compare 21 with 39, in which 39 is greater, so shift 39 here. Now we will compare 21 with 12 and 21 is now greater. So we will put 21 here, right? Now we will pick the last element, that is 56, and compare 56 with 81, in which 81 is greater. So 81 will come here. Now again we will compare with 67, in which 67 is greater. So put 67 here. Now we will compare with 39, which 39 is smaller. So we will put 56 here. Now we can see that the array is being sorted, right? So let's see the pseudocode. Now the name of this function is insertion sort, in which we have passed the array A. Now we know that the 0th element, we are picking the first element, right, which is actually sorted. So we will start from first index. So j is starting from 1 and going till n. Now we will take key as a of j, right? So inserting the a of j in a sorted sequence from 0 to j minus 1. Now we will declare I as j minus 1, and we will check using the while loop whether I is greater than 0 or not, and if a of I is greater than key. If it is, then what we will do, the greater element will be shifting to its right, and we will decrease the I, and at the end of the while loop we will simply put that key in I plus 1. Okay, so this is the insertion code. Now what will be the time complexity here? This loop is running for n number of time, and this loop is also running for n number of time in the first case. So since it is a nested for loop, the time complexity will be order of n square. And what about the space complexity? It is order of 1. Observe here, all the things are happening are inside the loop, inside the array itself. We are not taking any extra space here. So due to this, it is in place sorting algorithm. Also, it is a stable sorting algorithm. Okay, now in the next lecture I'll be explaining the counting sort. So thank you.